So thanks everybody for coming to this panel session. Look, Ma, no steering wheel. What we hope to do in this afternoon's session is to discuss sort of the state of self-driving technology and where it's going. If you follow the news at all, I'm sure you're impressed like I am with the amount of research and development that's going into what has often been perceived as a very slow-moving industry, the automotive industry, and the amount of development work that's going on from not only the classic automotive companies, but also a lot of startups. And as you'll hear from some of our panel members, there's a whole ecosystem developing in this realm. And amazingly, field trials and other tests, and just last week the U.S. House of Representatives passed legislation appropriately called the Self-Drive Act to try to maybe homogenize, if you will, if that's the right term, some of the regulations and so forth across the country. Because as you might imagine, if every one of 50 states comes up with their own self-driving standards, that's probably going to kill any adoption of the technology. But we'll get into that as we go along. I feel extremely fortunate to have had these four folks volunteer to come join us today. So I'll introduce them in a moment, but I mentioned what our objectives are, basically exploring the state of self-driving car technology, and I think one of the more interesting aspects of this is what are the potential impacts on society as we know it, and we'll get into some of that. We'll do introductions at the start. I have some focus topics or focus questions that I'll talk to the panelists about and try to solicit their views, and then we'll invite you to share your comments or questions where you'd like to get some insight from the panelists, or some of you may be working in this area and have some expertise to share as well. I will give you one caveat, and we did this last year at the same time, that some of the things that people are talking about, obviously this is a nascent market, it's developing. None of us knows exactly where it's going to go, and so I don't want to put our panelists in the position of thinking that they are representing their company's position necessarily. In some cases they may be, in some cases their perception may be different, and they're certainly not giving you investment advice about what stocks to go buy in this emerging market. So that's the safe harbor statement. So our panel members today, and I'll give you a little bit of biography of each of them, and then we're going to take a moment where each can talk a little bit about the work that their company is doing in this area and their interest in self-driving technology. And I've kind of ordered this in alphabetical order by company name. So starting with Analog Devices, Roxie Paine is the Director of Autonomous Transportation Ecosystems at Analog Devices. Analog Devices has been making some interesting moves in the last year or two, really appearing to take on more of a systems approach to this technology. Roxie is interesting. She said her passion for automotive safety actually started in high school when she took on a project aiming to solve the problem that first-generation airbags were killing short drivers. So that started her interest. And prior to her current role, she was at Analog Devices, the manager for LiDAR. So we'll, I'm sure, be able to hear some about LiDAR versus radar. And also worked in, you may be familiar, ADI has a number of MEMS products for the automotive industry targeting safety. So she has experience in that area. And she has a bachelor's degree from the University of Maine and an MBA from Florida Tech. Cory White is from Anritsu. He's the Connected Device Business Manager, Business Development Manager at Anritsu, and he's responsible for leading the company's automotive strategy. And of course, Anritsu, I'm sure all of you know, is very big in test and measurement, and the whole question of how do you test these systems, particularly if you think about it in a production line with cars coming off the production line and trying to make sure all these systems are working, that's not a small challenge. He comes to Anritsu with more than 20 years experience in wireless, connected vehicle, and infotainment industries, and previously he was at General Motors, where he was involved and instrumental with the OnStar division and the launch of that service. In fact, received the GM Chairman's Honor Award for increasing the volume and revenue of XM satellite radio. So he's been in the automotive market for quite a while. He has an MBA in global management and a BA in international relations. Then Jeff Coote from Autoliv. He's the director of customer programs for active safety and comes with 34 years experience in engineering and product management in the automotive electronic equipment supply industry. For the last 17 years, he's been with Autoliv. If you're not familiar with them, they're a major player in automotive safety subsystems, both passive and active. Jeff started out on the passive side and then shifted over to active safety. He's been involved in radar, monovision, stereo vision, far infrared, night vision, and more recently LiDAR. I think maybe we're getting too many LiDAR people on this panel.
Too many MBAs as well.
And the thing I think in Jeff's bio that's very interesting to me, and hopefully we'll get into it, is his current focus is on the robo-taxi and non-traditional automakers, so that's pretty interesting. And he has a bachelor's in EE from Kettering University in Michigan and an MBA from the University of Michigan, so 3 for 3 so far. And then Alex Wyglinki is Associate Professor of Electrical and Computer Engineering at Worcester Polytechnic in Worcester, Massachusetts. If you come to Massachusetts, it takes you a while to learn how to say those Massachusetts words. He's founded and is the director of the Wireless Innovation Laboratory at WPI, which is one of the leading research centers in New England. And they're doing a lot of work on next generation wireless technology, and a number of the applications they're looking at have to do with autonomous vehicles. So a couple of examples of that, they're doing autonomous and semi-autonomous decision making, which is, as you might imagine, a key enabler of self-driving cars. Also looking at automotive cybersecurity and vehicle-to-anything connectivity. So we have a lot of experience, and I want to thank each of you for being here, particularly our 2 folks from Detroit who had to get on a plane and come down. So at this point, what I'd like to do is let each of our presenters speak just for a minute or two about some of the work that their companies are doing, to give you a sense of what their companies or organizations, in the case of WPI, are trying to accomplish in this self-driving space. So we'll start with Roxie.
So good afternoon, everyone. As Gary just mentioned, my name is Roxie Paine, and I work at Analog Devices. Analog is actually headquartered here in the Boston area, so I actually am a local person. And at Analog Devices, we've actually been supporting automotive safety applications for over 20 years. We started in producing the first monolithic MEMS device to detect when a car is crashed, to then deploy an airbag. And since then, we've supported both passive and active safety applications within the vehicle around safety critical applications. Moving forward, as we talk about autonomous driving, we have a philosophy at Analog Devices that we now have trademarked called Drive 360. We feel that you need to have 3 sensing modalities completely around the car to provide a real-time 3D map. And these 3 modalities include radar, LiDAR, and cameras. At Analog, we are specifically focused around radar and LiDAR. But we work with our strategic partners and fuse that together for cameras to provide the data necessary, and we'll talk about it, I'm assuming, during this panel, as we move towards artificial intelligence and deep learning neural networks so that the cars can then train themselves to recognize the environment around them. So in addition to giving the car essentially its eyes, we are also focused on giving the car its sense of feeling. And we do that with our MEMS devices in the form of an IMU, so an inertial measurement unit. So a lot of times what people don't realize is when you're driving, how much you take for granted, how much you use your sense of feeling. So for instance, if you go too fast around a corner, you notice that, you feel that within your body. So you actually will take corrective action, whether you slow down or you don't go so sharply into that turn. So it's very important that those cars also have that same sense of feeling. In addition, the IMUs also help with dead reckoning and supporting the GPS system. Thank you.
Great. So we'll go to Anritsu, Cory.
Great, yeah, thank you all again for being here today as well. Our primary focus or our subject matter expertise is in millimeter wave, but also in wireless connectivity. So you can see from the connected vehicle perspective, we have a pretty broad product portfolio. Specifically in the wireless connectivity, our areas are 2G, 3G, LTE, and then obviously soon to be 5G will be a big focus for us. And then also on the short range wireless side, Bluetooth and Wi-Fi. We also work in the radar space under ADAS specifically, radar both in terms of sort of development side, chipset development, as well as all the way up to sensing radar target systems, as well as GNSS and ECOL for the European standards, ERA GLONASS, and then all those are tire pressure measurement systems and remote keyless entry. So all the short-range wireless options. We also do things inside the vehicle network for antennas and connectors, RF cables. We do a lot of work currently with the industry leadership around V2X communication, 802.11p, and also starting to talk in a great deal about cellular V2X with LTE and 5G. And then we also play in the over-the-air EMC and electromagnetic interference space. So we're primarily a hardware company, but we offer a lot of system solutions and test automation in that space as well.
Great. Right, Jeff.
Hi, so the company I work for is Autoliv, and we do only one thing, and that's automotive safety products. And we take it pretty seriously. I put a couple of things up here, our vision, mission, and values. So it's saving more lives. That's really what drives us. We've been encouraged to get into adjacent markets over time, and our board of directors has said no. This is all we do, and we stay focused in on that. And then where we're going, we know that from this accidentology that 95-ish% of the crashes that happen out there are due to human error. So it sort of compels us to be consistent with our mission statement to get into active safety, to try to reduce the severity or prevent the crashes altogether. So that's kind of where I've been working for the last 12 years in the active safety space, which is the radars and the vision systems, night vision systems. And then just to give some notion about how we do it, one of the things that we do is focus on what we call real life safety. Some of our competitors focus more, I would say, on the regulations. We try to, of course, we have to have our products comply with the various regulations around the world, but we want to go further than that. We have our own accidentology studies and stuff done by Autoliv Research in Sweden, which drives the development in that cycle from the active safety, passive safety technologies, doing those systems, deploying them, and looking at what happens to the real world safety and hoping that those numbers go down. Unfortunately, this year, over the last couple of years, they're trending up in the US. And then to give some notion about the timeline here of what the company looks like, started out in seatbelts in 1956, progressed through airbags. Then you see safety electronics, the electronics that sense the crash and deploy the airbags. I don't remember my own slide. Active safety, stereo vision, radar. We've kind of been over that a few times already. And then today doing driver assistance systems, and then moving toward autonomous driving task, the full functionality. I work in the space that is now sort of tongue-in-cheek, we call it robo-taxis, or the emerging non-traditional customers, a really eloquently named title for sure. Anyway, that's what I do, and that's the company I work for.
So we were founded in 1865. We have right now about 4,000 undergrad, 2,000 graduate students. We have sort of a preeminent engineering and science and technology education program, and we have a growing research program. My wireless innovation lab was started in 2007 when I arrived at WPI. It averages approximately between 6 and 8 funded PhD students, about 2 or 3 master's students, and about 1 to 2 dozen undergraduate students working on all elements of about wireless communications, information technologies, and their applications. In particular, lately as such, a lot of the funding and support for the research activities and educational activities in my research group have focused along the wireless connectivity, the connected vehicles space. In particular, we're looking at developing everything from modeling wireless connectivity between vehicles, especially if it's decentralized, where you don't have an access point, so vehicle to vehicle or vehicle to roadside infrastructure or a mix of the two. We also, through one National Science Foundation or NSF-sponsored grant, in collaboration with collaborators from the biology department, we are looking at artificial intelligence and biologically inspired learning techniques for radios being able to access spectrum dynamically between vehicles in order to have reliable connectivity between each other. So that's a 3-year grant that was awarded a couple years ago. Another grant that just got awarded earlier this year, sponsored through the NSF Cyber Physical Systems program, actually looks at sort of the connection between, the essential connection between wireless connectivity and reliable controls. And we're trying to show that you can't have one without the other, and the NSF is investing 3 years along with a collaborative mine in mechanical engineering, looking at how those two can have a unified theory in doing the connected and autonomous vehicles. We're also looking at vehicles as a collection of cars, as networks and computers. In particular, we're looking at automotive cybersecurity. So I had several graduate students and undergraduate students hacking into automotive CAN buses and such in order to analyze what are the apparent threats, being able to identify them, and then coming up with ways and countermeasures to sort of protect us from, that boogeyman that, we have 100 and some computers on a vehicle, and, it's kind of scary if you connect them to Wi-Fi and such. And so a lot of the work we do, there is obviously the fundamental aspect because that's what universities do best, but we also do proof of concepts as well, and we like demonstrating things. So that's in a nutshell. Thank you.
Thank you, Alex. So I think everybody now has a sense of where our panelists are coming from, and we'll launch into some of the discussion topics. But I will point out before I forget, after this panel discussion, there's a reception in the exhibition area, and Autoliv has a booth, and please go see their vehicle. You can talk to some of their folks about some of the sensor technology. You can see the LiDAR in the photo on top, and they have 77 gigahertz radar as well. So if you want to delve into more details, feel free to grab a drink and go by the Autoliv booth. So let's start. I guess my first question is, let's talk about the sensors from a hardware standpoint. So we've got clearly radar, we've got LiDAR, cameras. My sense is the industry seems to think that the autonomous vehicle is going to need a blend of those three technologies. I guess the first question is, would you agree with that? And then what is the state of those technologies? Are they ready for prime time? And whoever wants to start, Roxie, you can.
I'll get started. I think it's very fundamental that you have all three of those sensing modalities. And the reason is cameras are really good at telling you what an object is, or object recognition. But a standard camera is not very good at telling you how far away that object is. Whereas radar is fantastic at telling you how far away that object is, and also what speed it's traveling at. But unfortunately, it doesn't do a very good job of telling you what that object is. And then you add LiDAR into the mix. And LiDAR actually can tell you a little bit of information about what that object is, in addition to telling you how far away it is. And on top of this, there's some challenges around the resolution of each one of these sensing modalities, and then also the environmental considerations. Cameras by themselves are not very good in really bright light situations or low light situations. Radar tends to be one of the most robust in terms of some of the weather conditions, whether it's fog or rain. And LiDAR, depending on what wavelength you're at, there's different challenges around dealing with water and moisture in the air. So that said, it's really important that you use all three sensing modalities in order to come up with a proper 3D map of what's around the car. And so some of your sensors may be more confident in what it's seeing at a given point in time versus another sensor. And in automotive, we always are focused on safety first. As Jeff mentioned, that's fundamental, it's the most important thing. So in automotive, there's always redundancy. And some of the best forms of redundancy is when you have two different sensing modalities looking at the same exact spot to really be able to analyze and understand what's in front of it. And so from that aspect, firmly believe that all three sensing modalities are required. There might be different, requirements, technical requirements, whether that's the range or the resolution, given on where you might mount that on the car, so long range versus short range. But you need to have all three. And I think in terms of maturity, cameras are very mature, radar is very mature, it's been around for 15 plus years, most of it to date has been 24 gigahertz, we're now moving into 77, 79 gigahertz, and LiDAR is probably the new kid in town. And so there's a lot of different competing technologies in the LiDAR space right now, and there will start to, I think, be some consolidation in terms of what some of those winning technologies will be within the next 3 to 5 years.
Other comments from other panel members?
I think it's aptly put. What we see is sort of two different ends of the market. The radar systems, vision systems are sufficient from most OEMs' perspective to do up to about level 2 autonomy. As it moves past that, LiDAR is for sure in the mix. Probably not the one that looks like that. The styling departments aren't very fond of those. So there's a bit of a race out there with probably, we're looking at 7 to 9 companies who are going to do more compact, small, not 360-degree fields of view, but there's probably going to be 3 to 5 of those things on vehicles as we go forward, depending on what the mission is for that particular vehicle. So I think it's all three.
So in terms of LiDAR, one of the things I hear is the cost. And obviously the aesthetics of what's on the Autoliv vehicle is not great from a, I guess, auto designer perspective, but there seem to be a number of competing technologies, solid state approaches. Any comments from any of you on, it may be too early to bet on the winning technology, but how do you think LiDAR is going to evolve over the next couple of years?
I think you're right on the two things, right? The cost and then the sort of form factor. The cost has got to come down probably a couple of orders of magnitude from where it is today. And then I think from a form factor perspective, obviously solid state's preferable, I think, long-term to a mechanical moving part in terms of durability. Obviously an autonomous vehicle is going to be used, many more times per day than, thousands of times more per day than a current vehicle is used. And so all of the equipment, all of these sensors have to be, they obviously have to be automotive grade from the very beginning, but they also have to be built to be abused significantly more than most cars on the road are today. So those are key things. We haven't talked about V2X, but I do think the vehicle-to-vehicle communications, the mesh network that could come, likely from 802.11p, it could come from LTE, it could come from Bluetooth in some cases. That peer-to-peer communication is going to be also, I think, very important in terms of the long-term view of autonomous vehicles. Those are all pieces that need to fit in there.
So that raises a question, and I see you raising your hand, so I'll throw it to you, that the autonomous vehicle may not really be autonomous, and that comes into your comment earlier about being part of a much larger network communicating back and forth.
So in fact, I'm not sure if. Let me backtrack. So I'm not from my perspective, I'm not sort of thinking of things like LiDARs and radars and vision systems as sensors, but really just information sources to essentially one single decision maker. And absolutely right, in terms of the wireless to a computer, that's just another source of information for it, right? And this is unlike other sensors, or you will, or sensors. Like what it has the ability to go beyond just field of vision. Like, let's say radar has a certain sort of perception range, so does LiDAR, and so does vision system. You can go 2, 3, 4, 5 cars ahead and be able to see around objects that might otherwise be obstacles and find out exactly what the situation it looks like, right? So the situational awareness with that fourth source of information is a game changer. And that's why, like, there are folks out there that say, oh, but then it's not purely autonomous. But, as long as there's no human on the wheel, like, to me, that's autonomous. And if it means that cars have to drive, like this term has been brought up, the vehicular cloud, where you have a bunch of information that's suspended up there that vehicles can then pull down to make additional sort of decisions, like, to me, I think that as a source of information, as a sensor, is quite critical. And I think they're, right now, the ongoing battle in terms of wireless, that fourth sensor, is between the 5G folks, and 4G is already kind of paving the way for that, and the 802.11p and IEEE 1609 communities that are trying to see, this is a ratified standard, but it has some issues, like, limited number of channels, and even now, 5.9 gigahertz, is that going to be where we're going to play, or are going to be other bands? And then the 5G folks, which is still not quite ratified, although I think in South Korea, several manufacturers are actually trying to roll that out as quickly as possible. But already in 4G, there's some development with respect to an automotive grade type of connectivity that goes through an access point and the like. But really what it comes down to in the end is information into some sort of decision maker. And but I think the more, well, I might shoot myself in the foot, more is better, but then the price you pay is computational complexity.
For sure.
And then that incurs latency and issues along those lines.
So maybe to go back to the original question about the LiDAR,
Sure.
Maybe just to take a few moments to talk about some of the major LiDAR technologies. So for the first one is flash, and so a flash LiDAR technology basically is you shoot out a big broad spectrum area of light and you collect the photons that come back. And so this is really good for more of a short range type application. When you start looking at long range where you're going to push 100, 150, 200 plus meters, you then want to go into some form of a scanning LiDAR system. And for scanning LiDAR, there's a few different ways to do it. You can do it kind of like what you see on the Autoliv car here, which is a mechanical scanning mirrors. A lot of people are looking to move from a mechanical mirror to a MEMS mirror. And that is in some cases referred to as being solid state. And then there's a couple other technologies that are true solid state in the fact that they have no moving parts. And one of them is an optical phased array. And the other one that we have at Analog Devices is actually steering the light around using a liquid crystal waveguide technology. So just, I think that should summarize some of the different LiDAR technologies that are out there. And Jeff, I don't know if I missed any of them.
No, I think you did a very good job. And I think that what we're seeing is that there's just the pace of the development is just mind-boggling because the market's there, everybody recognizes. Which one wins? As you said in your opening statement, God only knows, and he isn't saying that.
So let's switch to, we've talked a little bit about hardware. Let's talk about Alex, you used the term decision maker, which is software, the way I interpret that. So what's the state of the software development for the self-driving technology? And setting aside for the moment the cybersecurity aspect of it, but just the artificial intelligence, the deep learning, whatever, that will allow me to take a car from my home in Nashua to my office in Norwood and not have to worry about it.
So at the North American International Auto Show in Detroit earlier this year, I think that was like the #1 word that was constantly coming up was, in particular, not even artificial intelligence, but deep learning. So what is old is new again, and what has happened is folks are looking at, and this is actually partly driven by efforts in another community, by Google and such, with a lot of their efforts in terms of how they intelligently search, tons of data and such in order to find patterns and sort of extract learning behaviors or patterns of, what can we sell this guy, and put ads and such. So what's interesting is there's been a massive push in the community, especially thanks to Google's Summer of Code, where they began sort of seeded several instances of here's all this deep learning software. You too can now develop your own. So in terms of actually being used out in the wild, test beds and stuff, well, obviously Google probably using with their platform and perhaps a few other vendors have been sort of very importantly trying to train their artificial intelligence and deep learning patterns, because it's still based on neural network technology. So there's a neural network, and then you have several other constructs that form sort of the deep learning, but you still need to train it. You need to train it for different scenarios and such. So what do? Well, nothing sort of replaces great experiences by going out on the road and then gathering that data and just running your AI, your deep learning thing over and over and over again. Then deploying it and then seeing whether it works or not. Now, that's really a bad scenario, because let's say you're going from Nashua down into Norwood or into Boston, which in my opinion, Boston would be a fantastic proving ground, because I'm not sure how many of you have driven in Boston, but without GPS, but it's or just with a blindfold. But it's kind of
it's almost worse with GPS.
So the idea is training for those instances where it might not have ever experienced. So based on past experiences, that AI, that deep learning construct will need to know, okay, what do I do? I see this white blob passing in front of me. Is it a pedestrian? Is it a snowbank? Is it another car running a red light? Or is it a seagull? Which there's a few companies have tested in the Boston Seaport area. Turned out to be kind of a very interesting circumstance when you have seagulls passing in front of that vision system, and it's like, what is this thing? So right now, everything is kind of experimental. Not a lot of people are talking about it, but you obviously have several key players in the artificial intelligence world working through it. And I think right now, what we're trying to do is trying to figure out how to make artificial intelligence more effective in terms of training quicker, and also how to switch. So there's a few techniques like ensemble learning, where what happens is, oh no, this is the wrong artificial intelligence environment. Like, let's say I trained this AI to operate in this environment. Oh no, but there's no snowbanks in this environment. This one has snowbanks. You go to your next neural network that has been trained better for that type of environment, and now you need a neural network of neural networks to decide where to go. So I think right now that is an open area of interest, and the number one sort of valuable commodity from the from the autonomous vehicle world is the data. If you can get any sort of data, training data, road data, and then you can test it on it, you're king, because then you can actually roll out these decision makers.
So clearly Google has been out accumulating a lot of data.
Yep.
Tesla has accumulated a lot of data.
Yep.
Do you see that these data sets and these neural networks will all be proprietary to a single company, or do you see at some point sort of a nationwide, like everybody will tap into a certain map that says, oh, that's a bridge, that's the Mass Pike over 128, or Google, GM, Ford, everybody's going to have their own system?
Yes.
Yes.
But it would be fantastic. I would say if, let's say, an organization, so like, from the academic standpoint, everything we do, like, whenever we do NSF, we have grants, we have to do a data management plan, which means we have to share publicly what we found out there. Now, some companies might not find it in their best interest to do that for whatever reason, competitive edge or otherwise, but I think eventually the sharing of this data helps us all. It makes our product, makes these products, these platforms more safer. It allows folks to train their AI on scenarios that they might not experience in other scenarios. So driving in Miami might be very different than driving in North Dakota. So, but I think data for the software side is critical.
So Cory, you have experience from General Motors.
Not too much with the. So for me, this is one of the things that's really interesting about AI is it gets down to what's the drive path, right? So the autonomous vehicle has to determine, in whatever situation it's in, how to get from where it is to across that intersection or whatever it is with all of these potential hazards and objects. And so it has to take what information it has on board already through a developed map from different sensors, from open source maps, whatever it is that all other sensor data that's been loaded, and then it has to apply what it's seeing with its sensors and feeling from its sensors, and it has to say, how is that different than what I'm expecting? And then how do I weave my way through that? And so what's interesting to me is the data fusion in the middle of it, right? So taking all those sensors, which we have on board for redundancy,
right.
And then figuring out whether it's a seagull or a truck, and then figuring out how to move, or in which direction is it going and how fast, and is it above me or below me, and then moving to a safe place where it can get through that. And so there's a lot of computational power that needs to be managed and harnessed in that case. And so the other question is, now you have massive amounts of data on board. The question is, where do you process that, and how do you make that happen in with super low latency?
Right.
And so certainly we're moving towards super low latency with 5G, but the reality is not all of that's going to be able to be done. You're not going to be able to send all the data up and have it compute and come back in the amount of time that you need to make that happen. So a lot of the computation has to happen on board. So you have this edge computing that has to happen. And so the question is, how much can stay on board, and how much can be pushed up into the cloud to get additional data and additional computation. And I think there's also a philosophical view of this as well, right? So some companies are out there building, some auto companies are out there building a huge detailed map set that they use and they download for a certain radius around the car, and then when they get close to the edge of that radius, they have to download a new set of it. So you have an OTA thing going on there, and over there download. Other companies want their vehicle to be completely in a silo. They don't need to be connected at all. So they need to be able to make all of the decisions on board. And so there's philosophical differences, and then there's obviously huge technology differences, both on the software and the hardware side, trying to make all these things happen. It's fascinating.
Roxie.
And I think the other piece of this, we've been talking an awful lot about artificial intelligence and deep learning. And so one of the things that's a fundamental shift for automotive is most of our ADAS or advanced driver assistance systems today is all based on algorithms or fixed logic. And so, we need to make sure that we have robust, functionally safe or operationally safe vehicles. And for that, we actually need, and people are still trying to sort this out, but we got to focus on where we use AI and deep learning and where we use fixed logic to make sure that we have safe vehicles driving down the road. And there's different schools of thoughts on this. A lot of people are talking about potentially just using AI to provide that real-time 3D map around the vehicle. So, training to know that's a seagull versus that's a tractor-trailer truck versus that's a child. But when it comes to actually driving the actuators, that would be based off of a fixed logic methodology. But the verdict's still out on this. There's a lot of different schools of thought, but that just happens to be one of them.
So one of the interesting use cases I've read about is, and it would be a classic example of Boston, the autonomous vehicle pulls up to a red light, and you've got swarms of pedestrians crossing the street, and the light turns green, but the pedestrians don't stop, and so the car is in a defensive mode, and it never moves again, because the pedestrians realize they can take advantage of it, and until it's midnight and the pedestrians have all gone home, the car can't move. So is that a real world issue, or is that science fiction?
Yeah. So most definitely. So there has been discussions about gaming the AI. So there's actually two things. The problem with AI is, first of all, if you have a driver that's kind of savvy and it's overly cautious, which a lot of them are going to initially be, right? What's going to happen is, you're going to have a very aggressive driver and says, well, if I pop into, let's say, their kind of like, a safety zone, if you will, it will force the autonomous vehicle to back off. You're going to have an aggressive driver cut off the autonomous vehicle almost every time, right? And pedestrians is another thing, that because in Massachusetts it's like, oh, there's an intersection, oh well, no one's going to hit me and just walk right out, right? The other thing is also kind of that leeway that we love to do, and again, Boston's a great use case in the wintertime where you kind of have 2 lanes of travel, and then you have the snowbanks that take away half a lane. Us human drivers, what we would do is we would kind of nudge into the next lane, and then we would have kind of share it with the guy with 6 inches of separation. An autonomous vehicle will say, this does not compute, there's no whole lane, I'm just going to stay here and wait for a nice Boston driver to let me in so I can continue driving, which, that autonomous vehicle is just going to be there. Right?
So will the AI software control the horn as well?
It would be great, or some sort of I think so. Because that's the thing. Unless we have some sort of notch or something to make perhaps a less conservative AI. But no, but in all seriousness, I think that is. I think that maturity level is going to take some time, and probably also regionally too. Because how people drive in Kansas City is very different than how people drive in Boston, which is different than how people drive in San Francisco. So.
We've even seen it on something as mundane now as ACC, Adaptive Cruise Control. You see the moving back in the queue because of the built-in safety margin that's in those systems. So it's for sure going to go up an order of magnitude.
So it's only when everybody has the autonomous vehicle, or everybody has the same level of respect for the other car.
But these are theoretically things that you can teach AI as well, right? So it will be that way until such time as someone figures out how to load that data for all those pedestrians and figure out a way to manage that situation, right? So those can be taught.
But just for the panel here, we talked about having data used by everybody. There certainly is a business model angle to that says, well, if I've got big data, then I win. The other thing is the data is generally pretty sensor specific. So whatever the sensor configuration that you have on the car, it may not be useful to the next guy over. It's like, well, yeah, my radar doesn't see the world that way, so thanks very much, but no thanks.
But and that's exactly it. Like, you know, like the thing is the data is going to be definitely sensor specific, and then also on top of it, there's going to be issues like I think. I forgot who mentioned about sensor fusion as well, like the alignment of the data, the resolution of the data. How are you going to bring that together?
Synchronization of the data.
I think it's going to take a little while in order to, but yeah, I mean, but at least as a starting point, you can always train your initial AI, and then afterwards, if you, like, you know, in Massachusetts, we actually have, I believe, already a protocol where you can test your autonomous vehicles on the road. So it's like, I believe, with whatever municipality you want to test in, Massachusetts Department of Transportation and the company, you can sign an MOU and actually, you know, sort of set out, like, you know, deliverables, specs and such. And already one company is doing this already, and you can gather your own, or even test it off-road initially, which I think is typical in most auto manufacturers.
But I think what's, you know, really critical to what Jeff was just saying, though, is that the AI and the training is really going to be sensor specific and also vehicle specific on where you mount those sensors, what sensors you have, and how they're all fused together. So what might work on a Camry may not work on, you know, a large, you know, GMC Sierra pickup truck. They're two very, very, very different systems. So there's definitely not a one size fits all in this case.
So let's switch for a moment. I'll ask Cory, since you're part of Anritsu and from a test program, and just thinking.
No pressure, no pressure.
For a moment at the hardware side.
Yeah.
What's the sort of thinking in terms of how do you test all these sensors as the car is coming off the production line so that you know, somebody doesn't get out and turn on their ACC and it's like, whoops, it's not working.
Yeah, well, so, I mean, wireless testing is one thing, certainly RF testing is one thing. But between, you know, cameras and LiDAR, you need alignment is really the key, right? So ensuring that, and, you know, and radar as well. So ensuring that the signal you're sending out, whether it's radar or optical or whatever, is received and by the receiver, and that it's aligned and calibrated so that it's working. And I think there's, you know, it'll be interesting long term to see, again, going back to my comment about how thoroughly used autonomous vehicles will be, you know, being on the road all the time, how those sensors, whether they need to be replaced or degrade over time, that'll be an interesting thing. How do you service those sensors and make sure they are exactly the way that they should be so that the vehicle can work the way that it's supposed to?
So do you see an anechoic chamber and some kind of a visual alignment chamber at the end of every auto production line?
No, definitely not. I mean, you'll have to figure out a way to, I mean, you guys build LiDAR, so you probably have a better sense of that than I. We don't test LiDARs or cameras, but you know, we do RF testing. In RF testing, you can do pass-fail, you know, with a device that we build or a lot of other companies build as well, for short-range wireless, you know, Bluetooth, Wi-Fi, LTE. Test all those things at the end of the line with fairly simple testing equipment. But yeah, but on the more optical side, you know, it requires, you can build using mirrors, you can build to the range you want, the right type of thing. But
I think to add to that, you know, one of the things that we've been looking at a little bit more is using MEMS devices for some of this, you know, alignment, especially out in the field, right? So, you know, especially in Boston, I'm sure no one in this room has tapped another car while parking. This is a perfect opportunity for some of these sensors to get put out of alignment. And it does become critical if it gets bumped one too many times. And so that's one area where just mounting a MEMS device into that box, if it's a small bump of alignment, then you can correct for that alignment in software. If it becomes a massive misalignment, you can actually then go and flip a flag going back to the domain control unit and say, hey, look, this sensor is completely out of alignment. It needs to go into the shop and have someone realign it. So there's definitely some technologies out there, you know, MEMS just happen to be one where you can address this problem.
now, it's an interesting point, though, because you know, in today's environment, a body shop or a car dealer not equipped to align radars and LiDARs.
Right.
So, and they won't spend money on that, right? Unless they're absolutely forced to. A dealer's not going to spend thousands, tens of thousands of dollars on test equipment. So there is definitely an opportunity for you know, the right player to get into that market and understand how are we going to test these sensors and realign them when they get really out of whack. or replace them.
Market growth for Anritsu if they're a car dealer.
But the reality of the fact is that none of them require alignment, with one exception at the end of the line for an OEM, and that is typically an ACC radar because of the range and the angular resolutions required, angular accuracy, sorry. So they'll allow that, but they hate it. The dealership issue is still here, and on all of the other sensors that we put on cars, radar, vision systems alike, we have to guarantee that the installation, it will be nominal, and we'll have to tolerate whatever variation there is in manufacturing. Auto alignment in the field for sure, because they're gonna heat and cool and get bumped and all those sorts of things, and then the ability to diagnose when you've had a very bad day and you got to take it to the shop. So there's a lot more work there than I ever anticipated when I joined into the active safety space. I just assumed that there was a lot more freedom to do alignment at the end, and not at all.
Well, that's a good point, right? I mean, the OEMs, when they're talking about final assembly, they're not going to accept products from a subsystem that isn't already aligned, right? So except to your point, the ones that require that sort of final alignment. So, a tier 1 supplier will be required to bring, if it's a light module with a radar in it, it's going to have to be fully aligned. And the reality is, where we'll probably end up on the dealer side is, they'll say, give me another one of those lights, and we're going to put it in.
Substitute it.
And they'll just get rid of the other thing. That's likely how it would be, rather than try and build out an entire infrastructure around
And the trajectory at the OEMs is always, okay, grudgingly, I'll let you do this for this model year, but you better find out a way to get it out for next year.
And I think the other challenge that we're all faced with, especially when it comes to cameras and also LiDAR, is where you mount them on the car. And you have to make sure to keep those lens covers clean. And so, salts and bug guts and things like that are always a challenge with making sure that you have clean lens covers. And
Well, to that end, we sell far infrared night vision systems today. They can't be behind glass because they don't see through the glass. The wavelength that we're looking at doesn't penetrate. So we've got a lens outside in the elements, and we have to actually design and work with the folks that do your windshield wiper sprayer, and it's got to be a turbulent enough pattern and all kinds of stuff. There's a whole bunch of science that goes into that to make sure that we keep that lens clean.
Yeah, the other thing we're starting to see that's interesting is we just started working with a company that does a lot of different radar technologies, and one of the things that's really growing right now is materials measurement, because there's so many radars and different sensors that are going to be put behind various different types of materials that you need to know the properties of those materials so that you can adjust your sensor to account for those properties. So it's
it turns out that the bumper, so we mount a lot of radar behind bumper fascia. Right. It turns out there's a guy that works in Southfield, and that's all he does. And because of the radar properties of the fascia, it's not delivered to us, so we cut out coupons, we take them in and measure them, and then he models it, and how many coats of paint, and how much metal in the paint, and what about the the repair shop? They don't care how thick the paint is. That's right. So it's a real challenge for us.
That's right.
So let's shift a little bit to kind of the impact on society. So I think in the last, year, a little bit over a year, there have been several Tesla accidents that have led to fatalities, at least one where the car went in under an 18-wheeler truck. So far, it appears that the way the regulations are set, and of course the caveats by the auto dealers or the automotive manufacturers that are providing this technology, is that you can't treat this as a true self-driving car. So as we start to move to the other SAE levels, how do you think the whole insurance thing is going to sort out?
And I think they don't know. I think they're grappling with this, and what does the liability look like, and what are the safety benefits? And the unfortunate equation is that as we move to more and more higher levels of autonomy, the roads probably will be safer, but there's going to be a mistake. And so even if it's 100 to 1, what does that equate? Even if it's a substantial societal benefit, if you cause one, well, I don't want this. So what's the uptake rate and the trust of the systems? I think all very good and open questions.
I think the big challenge when you start looking at this, especially around level 2, level 3, where there's the human-machine interface, where in some cases the human driver has to have control of the vehicle, and then in other cases the car has control of the vehicle. And a lot of people will use the parallel with autopilot on a commercial aircraft, for instance. And I think it's hard to draw those parallels, because for the average human driver, you go to driver's ed once when you're 15 or 16 years old, and that's it. You're out on the road for the rest of your life. And right now, with the level 2 and level 3 cars, the very first models that are being rolled out, there's no standardization. So when the car wants you to take back over to the car, it's not like it's standard that you're going to get a certain alarm, or you're going to get a certain light that's going to come on. Every OEM is deploying it differently. And so it's going to be very challenging for people to understand and actually communicate with their vehicles. So I've been in a couple of cars that deploy some of this technology, and it's not clean when the driver is supposed to take back over, control of the vehicle. One car in particular actually was more of a jerky motion when you got close to the line because it had the weigh and keep assist. And at first, my first reaction was, well, wait a minute, why is that so jerky? I would have expected it to be a very smooth ride. And then I realized it was actually a human dynamic issue on why they were making it jerky. Because what's your natural reaction if you're a driver in a car and your car starts jerking? You grab the wheel. And so there's many different ways that we're going to have to start looking at how the machine and the human work together, especially around level 2, level 3. And this is one of the reasons why there are certain people out there that are jumping straight to a level 5 and saying, forget a driver, and any driver that's going to be in that car for testing or trading purposes is going to be a professional trained to drive that vehicle. Because the human, we're unpredictable. As Jeff mentioned earlier, it's human error that causes most accidents. And so it's going to be a very tough challenge to solve, I think, with this human-machine interface between level 2 and level 3.
I don't think there's going to be many that will do level 3.
I agree.
Most, I don't know. I don't know.
And describe level 3 just for those that aren't familiar.
Level 3
with
is
the
where
levels.
the car drives itself autonomously, and then depending 10 seconds, as the car says, oops, there's something coming I can't deal with autonomously, I got to get the driver back in the loop. And I would say that many maybe that's a safer way to say it, are saying, forget it, never is going to happen reliably, we're not going to do this.
So do you think it'll jump to level 5?
If it goes there, that's the question, probably level 4, but probably.
So level 4, think of level 4 as actually being geofenced. So that's one example of what makes a level 4 car. So it would only be able to operate in a given area.
And high definition, geofence means maps, and high definition, not Google Maps, really high definition stuff, typically.
Correct.
Can you define the different levels? I'm not familiar with that.
Level 2, which is out there today, is where on the highway, freeway, so you don't have to deal with intersections, and the car will drive itself when the driver says, please take control, and then do automatic lane change and manage the lane, keeping in the lane, dealing with the other cars, until there's a situation that the system doesn't think it can deal with. Then it says, here you go, it's back to you now. Level 3 is longer, doing more audacious stuff and then having the driver out of the loop. So level 2 demands that the driver's in the loop and actively monitoring. Level 3 says you can read a book or whatever, just as long as you can come back in 10 seconds. First of all, 10 seconds is a very, very long time on the road. And it also, almost all the research that I've seen, you may know more, says there's no reliable way to get the driver back. And even if buzzers and bells goes off, a lot of times they don't know what to do.
Right.
Yeah. So the question of graceful failure, like especially when you have a system that, as opposed to, let's say, aircraft where the autopilots or even a car, right now with cruise control, it's like something comes up and it returns control back to the human, even at the higher levels and such. Let's say there's a mechanical failure, because these are still cars, right? So a tire goes or a brake pad or something happens. Going back to, I think, that vehicular cloud idea and the connectivity, I think is going to be really essential. Because, for instance, what do you do on, human drivers now when you have, let's say, something very serious, like your alternator's on fire or something? You lift a hood, and so people know, oh, okay, this car has actually failed, and you just kind of wing it, you go around. And I think that sort of coordination now that you, let's say if you have level 4 or, a really high degree of autonomy, how do now other vehicles know that you're in trouble? And you cannot take yourself to a point where you can actually remove yourself, or at least notify the environment around you that you're no longer operational if you lose that capability. That's a scary thing. We talk a lot about the mechanical side, the electrical side, with respect to MEMS and information and such, but there's also that mechanical element, and these things are kind of heavy still. So, and also going back in terms of another 2 ideas with respect to social implications, I just wanted to bring up is, first of all, the all-time low with regards to the society's perception about driving these vehicles, right? It's like, oh my God, like, I know my parents, they're like, I tell them every time, oh yeah, I'm working with autonomous vehicles, and they say, hell no, we're never going to drive this thing, it just sounds awful and such. And then the other thing which is tied to insurance is also liability. Like, so it's like, is it the owner of the car that's liable for his car going through that fence of that backyard? Or is it the car company? Or is it the software manufacturer of the deep learning? Or maybe it's one of the components, like the LiDAR, the thing did not work properly, or in order to clean off the lens or whatnot. So I mean, there are a lot of these sort of socio-economic kind of concerns that are still need to be resolved. And then, of course, legislation, which is, it's great that, at the federal level, there's discussions about it, and some things are moving along, but at the state level, like the harmonization is critical. So having some sort of federal guidance with that. But
yeah, I mean, with respect to the insurance side of it, really there's two things from my perspective on this, right? The first you just mentioned, which is who's liable for this, right? So insurance is predicated on somebody having ownership of that issue, and right now it's not clear, in future land, right? Who's going to be the owner of the vehicle anymore, and who's going to be liable in that situation? And the second thing from an insurance perspective is actuarial data that drives insurance rates based on history. Yeah. We do not have history right now, and so there will need to be some history built up, and so there'll be a lot of risk built into whatever insurance rates you pay, whoever the liable party is, which we don't know either, will have to pay some insurance policy on something that the insurance company has no idea how to risk right now. And so really an interesting space, and I think a lot of work to be done, but a lot of unknowns.
In fact, that driver history, it's like, how will the insurance company even know? Like, when is the autonomous vehicle? Or let's say if it's a lower level SAE classification vehicle, human operated, like, the track history, or if you tweak or modify, like, so that there is a community, a growing community in the United States that also modifies their own vehicles. I'm not sure if I'm not going to mention who, but what happens is they tweak, they adjust. What happens if, let's say, a lot of these softwares, like, were like, or implementations of autonomous vehicles have been modified, right? Customized. And now who's liable? Like, I cut this open, so now warranty's over, so now you're liable and such. And it's unclear if, let's say it's a high-res street map or something, and it's from OpenStreetMaps or some sort of open source. Now, it's opening up a lot of ramifications, because more and more of these things kind of are like, kind of like in the spirit of the maker movement. You have a lot of folks that will do all this sort of customization, and it's unclear how the insurance would work around it.
So I think from a liability standpoint, there's two different things that we're grappling with in this space. One is, what does liability look like for level 2 or maybe level 3 for an individually owned car? You go to the dealership, you buy your car, it's yours, you know who built it, and it's whichever one of the car companies, and that probably is a little bit clearer where the ultimate liability resides. Where it's far less clear is in the robotaxi market, where generally the model is that company X is going to own the fleet. They're not selling it to anybody, but you get in and ride in it. And you get it's a service for you. You get driven to where you want to go for a bit of money. That liability equation is very, very different, because it's company X. I own them all. I know where they all are. I can talk to all of them at any time. If there's a problem, I know it. The car is radioing in and telling me, and I get it to a depot and get it fixed, or execute a minimum risk condition maneuver and all that sort of thing. So they're similar but different problems, I think.
All right, let's open the floor to questions. Eli, I know you wanted to ask something or comment.
I'm a little skeptical about the whole thing.
Only a little?
It's such a complicated thing. I know driving in the suburbs even, I drive down this road all the time, Wallstead Street there. I don't see how you can do that autonomously. It's just too uncertain. You got people crossing going outside their lanes and road turns. How's the autonomous sensors figure it all out? It's just. Is there anybody doing that?
You need to take a ride in a Tesla.
Yeah.
What?
Take a ride in a Tesla. Find somebody who has a Tesla.
Is anybody doing it? I read that some buses are doing it, but I find it hard to believe. Out on the West Coast, I read.
Well, yeah, no, I mean, the trials that they have right now in Silicon Valley, right? Like,
Yeah, but then they always have somebody in the car to.
Well, that's partly, the engineer making sure that everything is like checked.
Right,
this thing is
right.
not freaking out. Check. This thing is not freaking out.
Truly
Check.
autonomous.
Yeah. No, I mean, no one's actually on
I
the
also
wheels.
worry, let's say I have an autonomous car, I have to go to Boston, park.
Yeah.
It's gonna know where to park?
Well, here's the thing. So here's a negative. Here's a negative. Oh, sorry.
Go ahead.
So here's a negative side that I think Roxie's comment about like parking and parked cars and stuff. So there is like some of the sort of negative side of autonomous vehicles is the so-called zombie car. What happens is like you step out, you go shopping, and it's like okay, autonomous vehicle, just drive around, do 20 loops around the block and pick me up. Like I remember that 20 years ago. That's like when I was young, my parents would drop me off and say, okay, Alex, get like 5 oranges. There's impossible to find parking. We'll just circle around. And so there's a risk of that being very horribly ungreen, right? So, but I mean, there are companies out there that are actually focusing on autonomous parking and
Valet, they call it.
valet parking.
And it's coming for the individually owned space sooner than the robo-taxi guys. There's another one that's driving innovation I think is really interesting. It's these shuttle companies that only operate on like a industrial park or a university or whatever, and they have business models that show them making money in the next year. And they're going to go do this, and they're going to do it in a way that it's all monitored, it's low speed, it's...
They have an infrastructure probably.
They do, and they said, one of the companies we talked to said, we're going to, you know how we're going to do it? We're going to cheat. We're going to, if we need to put some, something on the corner there, a beacon of some sort, we're going to do that. We're going to watch how things unfold and where we have problems, and we're going to fix them.
You might have it with self-driving, you go to the airport, and you go someplace and you can let the car automatically park.
But even in airports, there's these autonomous shuttles going. I forget where it's in Europe. I think in
I
France.
don't know. They have the trains, but I haven't seen buses.
Heathrow.
I haven't seen
So-
buses autonomous.
We've got a question in the back.
Yeah, so my question is two parts. So what do you kind of see the vehicle-to-vehicle or V2X part of the technology? And also, do you think it's possible that it's going to be a cloud network that you enter a zone and you leave the control to that network and it takes control of the movement?
So Alex, maybe you can just and repeat the question so the mic picks up.
So I think the question is, first of all, I didn't quite get it about the V2V, V2X.
We have different sensors, radar, LiDAR.
Yep.
But what about the V2V, vehicle-to-vehicle or vehicle-to-everything?
Okay, so that's the first question. Then the second one is about the vehicular cloud, right? So the idea of like sharing information in a distributed group of vehicles without connecting to a centralized architecture. Okay, so right now, it's kind of unclear how to do, no, there is one ratified standard in terms of, like, from the IEEE that focuses on V2V, V2X and such. It's based off of Wi-Fi, like the 802.11p. And then the higher levels are like the 1609 that allows for both a single and multi-channel operation as well as cybersecurity as well from there. But that is, giving way to other forms of wireless connectivity. So 4G already has like several like really low latency versions that they're rolling out, and of course 5G will inherit that and make it better, right? But also there are folks looking at things like light wave communications, so about 6-7 years ago, I forgot which company it was. I think it was like Intel. They were rolling out like demos at a conference, like IEEE Vehicular Networking Conference, where they were using tail lights and headlights as light emitters for transferring data between vehicles in a row. So you could actually do that as a way of connecting vehicles with each other. But ultimately, the decision is like, first of all, the proximity of where these vehicles and what that information is going to be used for. So if the vehicles are like right next to each other, they'll need information fast with like very little latency. Preferably, if you don't go through an access point, the better, or a base station, the better it is. So that's why, like, those IEEE standards are nice. The other, but let's say if they're farther apart and you want kind of the broadcast information, then maybe cellular base stations might be. I'm kind of skeptical about infrastructure being used in a V to I context, because then that puts onus on municipalities and states and federal government to install that, and that is a very costly undertaking, so that needs to be justified. So I would say, at least at the beginning, auto manufacturers might need to focus on themselves and standardize across their own product lines. Maybe even if you have a big enough market share or a consortium, you guys share in a standard on how to exchange that information. But the cloud is essential, I think, as we make more decision making, that like, you know, every person takes a chunk or a piece of making decisions. Like, you have the local decision where the vehicle says, do I collide, do I stop, do I go faster, do I change lanes, do I turn left? But then there's also, like, especially if you talk with anyone in civil engineering, with flow control, like the overall flow, like, you know, which would be a godsend on, like, you know, the Mass Pike, where it's like, you know, why am I all of a sudden slowing down and then I'm speeding up and then slowing down? If, let's say, there was a global sort of decision making that makes an optimal sort of flow scenario, that could be done theoretically, because I don't know where the infrastructure would go otherwise. Some server farm in Silicon Valley, I'm not sure. So the idea of having that information and pieces of it shared across the, let's say, multiple vehicles, and they exchange it, it's both very tantalizing, but at the same time, the latency, especially for something that's like very immediate, is going to be challenging. So people are looking at 802.11a, I'm sorry, P, but there are other solutions that are coming on the horizon.
So one of the things that changed recently and has made cellular V2X or LTE V2X more likely, I think, is they're moving towards peer-to-peer communications in there as well. So previously, DSRC, one of the really big advantages was the ability to talk peer-to-peer, and they were sending these basic safety messages 10 times a second, and so you had very rapid transmission of very short messages with a real specific set of data in it. And so that release 14, that 3GPP release, just as the specs have been written just in the last few months, has sort of changed the way that the LTE stuff is coming out, and that's sort of really sparked the conversation, I think, industry-wide. And there's a consortium for DSRC, the Omni-Air Consortium, which we're a member of, that is trying to certify DSRC devices and labs and test equipment to bring that to market. But it's interesting, right? It's a 1999 spec. And I think what we're seeing to some degree in the market is anytime you add weight and cost to a vehicle, OEMs don't want to do that.
Right.
And we have a lofty goal of reducing traffic fatalities, but what we don't have is an ROI for companies that are building this stuff, right, at the OEM level. So it's been difficult to get that started, and part of the reason that people are leaning in some cases towards C-V2X is they're going to put an LTE or an 5G module in the car no matter what, because they need that level of connectivity. It's a little bit harder, it's more of a stretch for them to say, I also now have to put an additional Wi-Fi module in, either coexisting with that chipset or whatever. So there's a lot of conversation going on in this space right now. DSRC does some things better, I think, in some regards than the cellular spec. Yep. Certainly we're not going to get 5G rolled out at the latency, super low latency that we expect for a long time. So there's some value there, but it's a really open question right now, I think.
And I think, one final, last point on this, I think the other important factor around, looking at the 5G is you don't want your car to go, can you hear me now, right? And so it's really important that the car in and of itself can handle situations where it's not connected to the cloud. It has to be able to operate independently. It's great to have all that extra information, but it's got to be able to operate on its own.
All right, we have a question back here.
Yeah, I have a quick comment and a question. The comment is, I live in Detroit. Okay, I'm from Detroit, and people in Detroit absolutely love their cars. Okay, and Detroit has a terrible, terrible public transportation system because of that. So good luck. Okay. Now, I'm not trying to be negative. I'm all for this. I find your technology to be fantastic, but Detroit's going to be a battleground. I know that's where the car companies are. You can push it on the people all you want, but they love their cars. Okay, they're not giving it up, and they're going to want to be in their cars. They're going to want to drive the cars, and a lot of people are against it. I talked to a lot of people about this, so it's a very interesting thing. And trying to turn a city into a totally autonomous public transportation system like Detroit's going to be a big battle. First, because people don't want it, and second, because they don't have any money. Now, my question for you is, are you going to put any sort of countermeasures in the car? I can just see a rogue college student pulling right up next to this who has some savvy knowledge, okay, about electrical engineering and blasting you with some radar jamming and hitting you with a little EMP pulse and knocking the car out. You know what's going to happen. You know it will. Okay, I knew a lot of college students when I was in school that would be willing to do all this. We did it to police all the time. So, you know, what are you going to do for countermeasures?
So the question is countermeasures for the radar or LiDAR or whatever. Is that a problem? Is it?
Well, one of the things that the auto companies are very, very focused in on is cybersecurity. I know that's not exactly what you're talking about. We've deployed a lot of radar, and we have to make sure that we don't jam our own radar, that others don't jam us. There can be, there certainly are nefarious actors, not saying you're one of them, even though you are from Detroit. I'm from Detroit as well. And there's a bunch of activity around that. What does that look like? What can we do? What it does to us is those of us who deploy those systems in the field is to make sure that we can diagnose ourselves accurately. And that turns out to be a particular challenge. For example, if you don't get any radar return on your radar, is it that your receiver's broken or that you're out in the middle of nowhere and there's nothing reflecting? You know, so that's a challenge for radar, it's a challenge for vision systems and all of them. But that's one of the things that was mentioned earlier, that we have to find a way to make these things safe, to know the state that they're in, and to communicate that to the driver. In particular, what you're talking about, I just got jammed, I'm broken, I'm gonna let you know that your system is no longer available.
I think that's the other important reason on why you have different sensing modalities covering the same area of space as well, right? So yeah, you could still get some rogue college student somehow figures out how to block the radar, LiDAR, and the camera all at the same time through spoofing mechanisms. But you know, the chances of that happening are probably slimmer than some guy just jamming your radar.
I'm actually, like, you know, and that's something that you can probably pick out with your data fusion algorithm. You can say this data does not correlate with everything else, all the other sensors in the environment, sensing about the environment, and you can say, okay, discard or diagnose it later and just focus on this. I guess in terms of like maybe a little bit of a segue into cybersecurity, the scary one is not knowing that you're under attack and it's coming from within. So like, you know, there are several concerns, like for instance, supply chain security and such, like knowing that your components are actually secured to begin with and that you're plugging into the vehicle and it's doing exactly what you want, and then you realize, oh, the firmware got corrupted and it's actually sending messages to parts of the CAN bus that it really shouldn't and does bad stuff. And then, of course, you have, like, let's say, several other universities where they demonstrated over-the-air attacks where they actually get in, reprogram the firmware, and does crazy wonky stuff. Like, let's say, roll down, whatchamacallit, like your Windows without you commanding it, or, you know, some of the more well-televised type of attacks, like, you know, disabling brakes and such, and like, you know, and that's a scary thing. And the thing is, college kids can do that too. It's not just like, you know, taking a laser pointer. They can, you know, all my incoming freshmen, they all know how to program embedded devices, and you know, with a little bit of snooping around and figuring out how CAN bus works, they can cause a lot of damage.
And there's a financial motivation to do it. So that if you can hack a car, I have in my head that the scenario where, what's the movie where they had to go above 50 miles an hour or else the car was going to explode? I can imagine that thing happening and you get a blip on your screen that says, by the way, you're going to be going, you know, 50 miles an hour forever unless you pay me $5,000. Please hit yes.
Ransomware.
Ransomware.
So just real quickly to address the last part of your question about people, or the first part, I guess, about people not wanting to give up their vehicles. I was at a conference last year at University of Texas, and their computer science and transportation department there has done a lot of modeling around autonomous vehicles and traffic patterns and things like that. And they did a model of a single intersection with 4 lanes in every direction. And they basically said, okay, this is how long it takes cars to get through in today's environment with traffic lights, where one side stops, left turns happen, other side stops, left turns happen. And then they basically said, okay, in a pure 100% autonomous vehicle environment with a traffic manager where every car gets a lane at this particular time, you turn left, you go straight, whatever, and it just showed this crazy mismatch, but nobody ever even slowed down, right? Because they were able to manage that from a centralized location. But the most important thing, I think, and this goes to your point, is they basically backed the model down from 100%, and they said, at what point do we start seeing traffic get better when not all the vehicles are autonomous. And they figured it was about 40%. So even if only 40% of the vehicles were autonomous, they started to see significant improvements in traffic patterns. So, in the case of Detroit, I live there also. I know people are not giving up their Camaros or their you know, their Dodge Vipers and the things that these car guys, they're car engineers, that they don't want to give up, and they probably don't have to for us to still get lots of value out of autonomous vehicles.
And I think on top of that, even the people who still want to drive their cars, and I think that's fantastic, a lot of the technology that will come out of making a fully autonomous car will be backfed into the mainstream automotive device. So I mean, the reason that we have autonomous vehicles, there's two factors, right? There's safety and then there's convenience. And so when you talk about the safety element of it, let's just think about it as you start deploying some of this technology on your standard car as an ADAS feature. So let's say, you don't see a car coming and you're about to pull out into traffic. So you put your foot down on the gas. What happens if your car just doesn't go because it knows that car is there to prevent an accident? So I think there's definite uses for all the stuff we're talking about today back into a mainstream car that would have a driver.
So I think we have time for one more question.
I was just going to say, what about just random technical failures, software crashes, chip blows out, etc.? How do you deal with that?
Again, it's back to the diagnostic issue. There's a lot of diagnostics going on real time, checking memory, doing a zillion different things to say, am I healthy? Am I healthy? And when I'm not healthy, what is it? And what do I do? Do I limp? Do I notify the vehicle system, hey, I'm offline, I'm unavailable?
The computer that's checking that has a problem.
Everybody that's doing the fully autonomous vehicle that I know has 2 fully redundant paths for everything. And one manufacturer called it, big brain, little brain. So the main guy doing all the computation, then the smaller brain saying, if you tip over, I can at least get to a safe harbor.
And on top of that, that diagnostic goes all the way down to the IC level. There's a lot of ICs that are deployed into these systems that will have their own self-check diagnostics built in on board. So it goes all the way down to the chain.
One more, squeeze it in.
You have to excuse me, that's my first question to a panel ever. But
you're excused.
But I'm thinking in terms of the power supply. So I'm sure there's been a morning when you've gone out to your car and you try and turn it over and the engine doesn't turn over, right? Because you have a bad battery. How do you know that your sensors, they probably have some kind of operating region as far as power and current and voltage, right? How do you know that your sensors are working correctly?
We monitor the voltage.
Yes.
And when you start to go out of range, there's an orderly shutdown and a notification to the others that rely on the information you're providing. It's not perfect. We get it wrong sometimes, but that's a sort of a basic tenet. You got to be diagnosing yourself even down to that level, so you don't get a brownout condition and corrupt your memory or whatever.
So this is a fascinating topic. It's rapidly changing. If you do any kind of news scans that sort of follow this area, it's amazing. Certainly weekly, if not daily, there's an announcement of some M&A or some partnership that's being announced, or somebody's attacking a certain part of this ecosystem. And I don't know if we leave today from our panel with optimism that it's coming quickly, or, I think at a high level that's my sense, but then as I've listened to some of the little details that need to be worked out, it's not clear that that's going to be as straightforward as maybe some have said. But nonetheless, stay tuned. I think we'll probably do another one of these sessions next year and see how much progress we've made. And meanwhile, let's give our panelists a round of applause.